Hi guys. I was tired of using the traffic light example for OpenPLC, so I tried to find some different applications. And it's time to revisit an old passion for me. Alcoholism. I mean making cocktail makers. I made some in the past on my channel. The first one I made was this bulky one. It could mix 16 bottles. After that I made a smaller one, but with more features, like smartphone control over Bluetooth. This is the one we will program with OpenPLC. This series is not a step-by-step tutorial to replicate the end result, but more to show you what you can do with OpenPLC, and I also will take some time to compare the Arduino code with the PLC code. This series is not at all an excuse to day drink because of testing reasons. So first we will cover the process. You have 8 bottles of liquor and mixer to mix with. They are all connected to an individual membrane pump, and the output of the pumps comes together above the glass. Depending on the cocktail you choose in the user interface, the Arduino Uno will turn on certain pumps for a certain time to get the optimal cocktail. The hardware is just an Arduino Uno, an 8-channel relay board, a power supply and 8 membrane pumps. In the original design I also used a Bluetooth module, but we don't need this in OpenPLC. In previous designs I tried using a flow sensor, but I kept having problems with counting the airflow instead of the fluid. I tried multiple sensors, but in the end I just found timers more reliable. So here is the layout that we will make. So we have OpenPLC in the center, then we have an HMI. We will build it for PC, but you can also open it on your smartphone via your web browser. And the OpenPLC running on Windows will connect with Modbus to an Arduino Uno slave in the Cocktailmaker. That will control the relay boards, and relay boards will control the pumps to make cocktails. The first thing we will do is try out the hardware. So we will make a program to turn on all the pumps one after the other to test that we have connection and that they all still run. Because I didn't use a cocktail maker for like 1 year or so, first of all try to make it work and test your IOs or your outputs. We first start by opening OpenPLC editor and we create a new project. You have to create a new folder to save the project in, an empty folder. So I'll call this OpenPLC Cocktailmaker. And I will select this new empty folder, of course. Our main programming unit, I mostly call main, and we will program in FBD because I like FBD. Then we create a function block and we call it IO test for our testing program, and we will program it in SFC, so sequential function chart. I made a video about it, if you want to look more in SFC, right here. Then we add our step 0 and we add our first action to step 0. We will set a variable. Hi, but I forgot to add variables, so first we will add variables. I will call them output 0 to 8, so I will start by output 0. It's an output of my FB, my function block. It's the type bool, so either 1 or 0, and then I create my other variables. If you fill in the first one correctly, it will auto number, so you don't have to do that much. There are 8 outputs, so from output 0 to output 8. Now I can connect the action to step 0, so set output 0 high in step 0. Then we do a transaction with a connection, and the next step, step 1, also with an action. To go from step 0 to step 1, we will do this with a timer. So I want to set step 0 high and output 0 high for 2 seconds. And I want to set step 1 and output 1 high for 2 seconds. So I want to alter each output and set it on for 2 seconds in a continuous loop. So we add the ton timer, so that stands for timer on delay. And the output we will connect to the transition. To set the timer, we select output 0. So when output 0 is high, the timer will start running. And it will run for 2 seconds. So we add a variable with the expression time hashtag 2 seconds. We can connect it to PT. We copy paste this one for the next transition and we just change it to output 1. We add a transition with a connection and we will do the step. And we add the jump just to check out that our program works. We start the simulation. But before you can simulate, you have to call your function block up in the main program. Otherwise, it isn't run by the PLC. We select user defined and there is our block and we drag it in the main program. Now we can simulate the PLC. And as you can see, the SFC works. So step 0, step 1, and it continuously does that. So we'll continue doing this for all the outputs, so that all the outputs are 2 seconds on after another. So output 0 is 2 seconds on, then output 1 is 2 seconds on, and so on. So we can test out our IOs. The easiest way to do this is a lot of copy pasting. So I will fast forward this part because it's a lot of doing the same over and over again and it's boring to look at. The first step we will do also an AND port and we will connect an enable to it as an input so that we can in our main program connect something later on if you want to do the IO test or not. So we will define this as an input and we will call this enable IO test. So the class is an input. We drag and drop it and connect it to the AND port. Later I will connect it in the main to a variable if you want to enable the IO test or not. So now it's just a lot of copy pasting. After step 7, we want to go back to step 0. This will select a jump to step 0. We connect it to it. So after step 7, it will start all over again. Now we just simulate our code, but before we do that, we have to add a variable true in the main. We're just gonna connect it to a true, so the IO test is enabled. And then we're going to simulate it again. We click on the classes and then we can see it works. So each output is set for 2 seconds and then it goes to the next output. So it's good for testing my outputs in this case. Normally you just force the outputs and check if they're on or off. In other PLC brands, but because I have the lights for an indication for my relay board, it's nice to do it so. Now in the main, I will connect the outputs of my function block to the pumps I don't connect them directly to the outputs. This is because my relay board works on a low signal, so if it's 1, the output is 0, and if it's 0, a low signal, the output will be 1. So it works with reversed logic, so negative logic. I don't like to work in my program with negative logic, so I will just create variables pump1, pump2, pump3, and at the end of my program I will inverse them, so it works with the negative logic of the relay board. But in my program, pump1 is just positive. But you will realize it in a second or two when we are testing. So we connect our outputs of our function block to these variables pump1 to that you can select only have 4 outputs. This is the advantage of the openness of OpenPLC project. I can change the code for the Arduino, the firmware code, so it works differently. So first of all, we're gonna get the firmware code for the Arduino. So we click on OpenPLC Runtime and then Arduino boards. So the Arduino works as a slave. If you don't know what I'm doing here, you can watch my previous video on how to run OpenPLC with Arduino. So we download this firmware. And I will copy it to my project, so I know where it is. So I'll copy it in the PLC project. You have to unzip it, it's important, otherwise it won't work. I delete the zip file and we open it. It's important to don't change the name, otherwise it won't work. So this is the firmware. So we're gonna change it. We will also change the comments because yeah, it's what you normally should do. So we're just gonna have one digital input. I don't think we're gonna need it, but it's great to have there. And then the digital outputs are from 2 to 9. So 2, 3, 4 to 9. We change it also here. Then we have the analog inputs. We don't change anything at all, and we take one of the analog outputs away. We also have to change the pin mask. So we have also only one input, and I already uploaded it. But then we have to also change this code over here. So we only have one input. And still 6 analog inputs, 8 coils, and just 2 analog outputs. And then we upload the code to the Arduino. So this is the firmware code. It makes this possible for the PLC that is running on Windows to give and receive signals for the Arduino Uno. That's a slave device. After it's done uploading, we go back to the OpenPLC Runtime and we'll add our slave device. We add a new device, and because you can't change things of the Arduino Uno, we're just gonna a generic Modbus runtime device. So it runs through the COM port in serial. We will call it Arduino Uno Cocktailmaker. Slave ID is 0. The COM port in my case is 3. The baud rate, I have to check it out, is 115,200. Data bit 1, stop bit 1, transmission pause 0. Then for the inputs we have from 1 to 0, output from 1 to 8, the input register from 1 to 6, the holding register from 0 to 0, and then the holding register from 0 to 2. We add the device, and it's important, after adding a device, you stop your PLC and you run it again. Then it will accept the device and run the code to the device. We can monitor again and we can see it. And I also see the lights running on my Arduino relay board. The pumps don't run because the 12-volt power supply isn't connected. I do this because I don't want the pumps to run continuously. So you can see the relay board is working, so all the connections from the Arduino Uno to the relay board are working. And now I will turn on the power supply and I can hear the pumps running. So you will also hear each pump runs at a different noise. I don't know why it is, but it's only $4 or $5 per pump, so I can understand it's not that uniform, but they all work. So I'm happy with this result. In the next video we'll create the program for actual making cocktails. So if you don't want to miss that video, please subscribe and press on the bell icon. And I will see you in the next video.